A Docker multistage build is a super helpful tool I use every day in my container development process, though it seems not too many people know about it. If you already know how to create a Dockerfile, I promise you by the end of this video, you will immediately start using multistage builds for your own containers. We'll see what a multistage build is and what problems it solves, and then work on 3 practical examples from start to finish. If this is your first time here, my name is Manuel, and if you want to learn more about containers and DevOps, start now by subscribing so you won't miss any new content when it's available. A Docker multistage build is a special type of container build that allows you to break down your entire build in multiple stages. You can easily recognize a multistage build if in a Dockerfile you can count more than a single from statement. So, every stage starts with a from instruction and can run any number of build steps to generate its very own container image. At the end of the build, Docker will then commit only one of these images into the local container registry as the resulting image for the entire build. By default, this is going to be the image produced by the last stage in the Dockerfile, but you can also select a different stage. We'll see an example later in the video. But what's the point of having multiple stages if you can only produce one container image? Well, the beauty of multistage Dockerfiles is that you can also share data between build stages, and this means you can use one image for building your application code, and then transfer the generated binaries into a clean image with just enough software to run the application. At this point, you can probably tell what the main advantages of a multistage build are. The final image is typically a lot smaller than the one produced with a normal build. The resulting container will not carry around all of the layers generated by all stages, but just the base image plus the compiled application binaries and the minimal amount of software. And the side benefit of smaller images, they take less time to transfer over the network, so you'll also shave some time off of your build pipeline. Last but not least, the resulting container is more secure. Because your final image contains just enough software to run the application, there are fewer packages, hence less vulnerabilities potential attackers could exploit. So how does all this work in practice? Let's say that we need to build a Java application and we want to take advantage of multistage builds. We define the first stage from a Maven container with JDK11. And we can use the as keyword to assign an alias to this build stage. An alias will help us reference this stage later on in the Dockerfile. Then we copy the application source code and run the Maven build. This first image we created now contains a lot of additional data we don't need to run the application, like Maven, the JDK, and the source code. With the power of multistage builds, we can now transfer the compiled application into a new stage using a more specific base image. To create the second stage, we are going to introduce a second from statement, and this time we use Tomcat with JRE11 as the base image. If you've used Tomcat before, you know that to deploy an application, we simply need to copy the generated web archive into Tomcat's web app directory. For this, we can use the copy instruction with an additional option from equal to builder as the first stage alias, and Docker will copy the generated application archive from the builder stage rather than the host file system. If we build a container from this Dockerfile, the resulting image will only contain the Tomcat server and the generated web archive. It's that easy. We're now going to look at 3 real-world examples that we can use to practice multistage builds. As always, I do my best to make sure you can try this out for yourself. You'll find a link to this repository in the video description, so if you want to do so, pause the video and go check out the code now. I recently started studying GoLang, so for the first example, we're going to create a Dockerfile for a simple API I have created. The application is just an API endpoint that you can use to transform a string to uppercase, lowercase, or title case. We just learned that with multistage builds, we can use one container for building the application and then transfer the generated binaries into another target container. Let's start our Dockerfile by declaring the from GoLang 1.16 as builder. From now on, in this Dockerfile, we can reference this stage with a builder alias. Then I'll change the work tier to go src echo-go and copy my application files. Next, we want to test and compile our application. This tutorial is not about Go, so I won't be explaining these steps, but hey, if you have questions, feel free to leave a comment. I'm still learning Go myself, so I'll welcome any questions or pointers. Coming back to our container, the go build command generates a new binary file in the working directory called echo app. and we can just run it as a standalone application. Let's see if this Dockerfile works. We run a docker build and tag the image as echo. Then let's see if the application runs. Docker run, we bind the port 8081, and echo is the container image. So if we now hit localhost 8081 with some string /upper, it replies with the same string in uppercase. Good, the container works, but let's have a look at the image. The resulting size is more than 800 megabytes, a little bit too much for such a simple application. Let's break it down to the single layer with docker history echo. Of course, we are carrying around some pretty large layers from the base image, but I know for a fact that my application binary is about 6 megabytes big, so we have a lot of data in this container that we don't need. Let's go back to our Dockerfile and add a new stage. The goal here is to reduce the image size as much as possible, so why not use Scratch? When we use Scratch as a base image, we start building our Docker image from a completely empty layer. If your application needs the Python or Java interpreter, you're probably better off with an Alpine-based version of the Python or JDK image. But for a self-contained binary application, Scratch is perfect. All we have to do now to package the application is copy the binary from the builder stage. So copy, with the option from equal to builder, and just copy the binary file into this new container. We then expose port 8081, and the command to run is echo up. Save the Docker file, and we build the echo image again. If we have a look at the image layers one more time, we see it only contains the application binary, which is about 6 megabytes big. It's so cool that we were able to reduce the image size from over 800 megabytes to just 6. Now let's see what else we can do with multistage builds. We now know how to copy files from other build stages by using copy with the from option. But the real fun begins when you know you can also reference external containers. This includes existing containers located in your local or even a remote registry like Docker Hub. Why is this important? Let's see with the next example. I'm creating a container I can use as a Jenkins build agent to be deployed on the cloud. I need 2 different Java versions, 8 and 11, to build my software, then Maven, and then install some additional packages like Git. It will take some work to have all of this set up. Let's see if we can take advantage of multi-stage builds. We can use the Jenkins CI/JNLP-agent as the foundation for our agent image. And I know this image already comes with Java 8 pre-installed. In addition to that, we also need JDK 11. Do you remember how to install it? I don't. So why don't we copy it from the official OpenJDK image? Type copy from OpenJDK tag 11 JDK. And we copy the Java 11 distribution from user local OpenJDK 11 into the same directory in our container. And that's it. It wasn't hard work, was it? What about Maven? Let's do the same and copy the Maven distribution from its official container image. Again, copy from Maven tag 3-JDK-8 from the user share Maven directory into our container. I like to always keep the same location of the binaries to be consistent. Now we can teach our container how to locate Maven by setting some environment variables. Maven home, and this is going to be user share Maven, and update the path to include the Maven home/bin directory. Let's finish up by installing the Git client. Change back the container user to Jenkins, and we're done. Let's save and build this Dockerfile. We tag it as Jenkins agent, and let's run a quick test to see if it works. Run the container with docker run-it Jenkins agent bash to open a shell into it, and let me print the current Java version. It's 1.8. What if I need to use Java 11? Let me set the Java home to user local OpenJDK 11 and update the path with a new variable. And now I'm running version 11. And what about Maven? Let's type mvn --version, and that's working too. I hope you're starting to see just how much you can do with Docker multistage builds. Now let's move on to the last example. When you generate a container image from a multistage build, by default, Docker will tag the image generated by the very last build stage in the Dockerfile. But you can also choose to stop the build at any of the other stages. All you have to do is use the target equal to stage name option with the docker build command. There are two main reasons for using this feature. The first is to debug a specific build stage. Docker will not store the layers generated by the intermediate stages, so if something is wrong with the Dockerfile, there is no way to inspect the content of a previous stage from the committed image. Or second, you may want to generate different images of the same application for different purposes. For example, you can have in the same Dockerfile one stage to compile the application with debug flags, one to include additional data for testing, and another one for the final production image. Let's go back to our Echo application. For demonstration's sake, I've already prepared a slightly more complicated Dockerfile that features 4 build stages. The first is the old builder stage, to copy source code, install dependencies, and run tests. Second, you can see a new debug stage. The stage will build the application with debug flags and run it with a remote debugger GoDelve. Then we have a prod builder stage, and this time I just want to generate a self-contained application binary to run on production. And last, the production stage, where I copy the binary generated by prod builder into a scratch image. Notice how for the second and third stages I used builder as the base image. This is just a way to continue building upon a previous stage that's already closed. I structured the build this way so I don't have to repeat the steps defined in builder for both the debug and prod builder stages. Okay, now let's run some Docker builds. We know by default, Docker will store the image produced by the last build stage. In this case, it will be our production stage. Now let's wait for the build to finish, and again, verify this is our production image with a docker history command. And yes, this one contains only the application binary, and we don't have all the other layers generated during the build. Now let's see how to create a container image from the debug stage. All we have to do is run the Docker build and use the target option, so docker build from our dockerfile.solution2. This time we use the tag echo:debug. Then we use the target flag equal to the name of the stage we want to build, which is debug in this case. We wait for the build to finish, and let's have a look at the results. We can tell the debug image is different because of its size, and if we inspect the layers, we can see the instructions we use to compile with debug flags. And we've reached the end of today's video. I hope you enjoyed working with Docker multistage builds and learned how to include them in your development workflow. As always, if you have any questions, let me know in the comments below. Thank you so much for watching and see you in the next video.